let's look at non-standard series. So we have S sub n is equal to T sub 1 plus T sub 2 plus T sub 3 and so on up to T sub n. Now this we can write it in short as summation k equal to 1 to n of T sub k. Instead of every time writing this k equal to 1 to n, we can simply say summation of T sub k. It is understood that k goes from 1 to n. Now, what are the steps involved in this? First step is to write the nth term of the series, express the sum in terms of the standard series, substitute the series expressions, and simplify. So let's look at it with an example. We have S sub n is equal to 1 cube by 1, or it could be just simply given as 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus and so on. Now here we are not given the nth term. So which means we have to figure out what the nth term is. So here in the numerator we have the sum of cubes of first n natural numbers. And in the denominator we have the sum of first n odd natural numbers. So let's write it the nth term. We get T sub n is equal to 1 cube plus 2 cube plus 3 cube plus dot plus n cube divided by 1 plus 3 plus 5 plus and so on up to 2n minus 1. This we can write it in the summation form. We have T sub n is equal to summation of n cube divided by summation of 2n minus 1. Now in the denominator, we can split the summation into two summations. So it becomes summation n cube divided by 2 times the summation of n minus summation of 1. Now, since we know these summations, let's actually substitute the expressions for those summations. We have summation of n cube. We know that is n square times n plus 1 square by 4 divided by summation of n is n times n plus 1 by 2, and it is 2 times, so 2 times minus summation of 1, that is minus n. Now it's just a question of simplifying it. So we have 2n square plus 2n minus 2n divided by 2. Here 2n minus 2n cancels out. We are left with 2n square by 2. So 2 cancels. So we are left with n square. Now this division we can convert it into multiplication by taking the reciprocal. So we have 1 by n square. So Tn is equal to n square times n plus 1 square by 4 times 1 by n square. Here n square and n square gets cancelled, and we have the nth term of the series. That is T sub n is equal to n plus 1 square by 4. So now we have the nth term. We take care of the summation. So S sub n is equal to summation of Tn, which is equal to summation of n plus 1 square by 4. Now 1 by 4 is going to be a common factor for all the terms in this summation. So we take it out. So we have 1 by 4 times the summation of n square plus 2n plus 1. Splitting this summation into individual summations, we get 1 by 4 times the summation of n square plus 2 times the summation of n plus summation of 1. We know the expressions for this. We substitute 1 by 4 times n plus 1 times 2n plus 1 by 6 plus 2 times summation of n, that is n times n plus 1 by 2 plus summation of 1, that is n. So now let's simplify. We have n square plus n times 2n plus 1 by 6 plus 2 and 2 cancels, n square plus we have n here plus n here because 2 and 2 would have got cancelled. So we have plus 2n. We continue simplifying. 2n cube plus 3n square plus n by 6 plus n square plus 2n. 2n cube plus 3n square plus n plus 6n square plus 12n by 6, which gives us s sub n is equal to, n is common, so n times 2n square plus 9n plus 13 divided by 24. So this is the expression for the summation of the series up to n terms. Now, how do you verify this? First, make sure that it gives you the summation of the first term itself. It should give the first term itself. So s sub 1 is equal to 1 time 2 plus 9 plus 13 by 24, which is 24 by 24, which is 1. So first term, great. Now check for the second s sub 2, which is the sum of first two terms. So using the formula, we get 2 times 2 square, that is 8, plus 9 2s 18 plus 13 by 24, which gives us 39 by 12, which is 13 by 4. We know this is actually correct. You basically verify it manually by adding the first two terms. We have 1 plus 1 plus 8 by 1 plus 3. We get 1 plus 9 by 4. And if we add these two, we get 13 by 4. So that was non-standard series, and how standard series can help us in figuring out the expression for the sum of first n terms in the non-standard series. Now, if you found this session helpful, don't forget to like, share, and subscribe. Comments, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.